Okay, let's start with the first question. Okay. A force of 6 Newton, okay, acts on a stationary object of mass 2 kilogram for a period of 12 seconds. So this is actually a very simple question. I think it's in par with a SPM question. Right. Let's see. For question number 1, who can give an idea how to answer this kind of question? Anyone here have the idea how to solve this kind of question?
F equal ma.
Yeah, F equals to MA. F equals to MA came from? Came from where? First Newton, second Newton, third Newton.
Second.
Second.
Second, second
Second
Newton.
law, sir.
Second law. Okay. Before we start the question, before we start to answer this question, I have to remind you in SPM, Newton. You may say, or you may define that Newton say F equals to ma, right, in SPM. But in STPM, Newton didn't say directly F equals ma. In definition of the second Newton's second law, what he said or what it states that the force, okay, the force. Can you see the screen or the writing on the screen?
Can see.
Okay, the force is equals to or proportionally it equals to change of momentum divided by change of time. It's the rate change of momentum. And momentum is F, or we can say that F equals to change of mass times with the change of velocity, mv. Momentum is mv divided by change of t. Okay, so you can see that this is not, okay, this is not directly, we can say that this is equals to F equals to ma. This is not directly F equals a. He didn't say F equals ma. But because of the SPM is much more lower level than us, right? We assume that the mass is constant. Okay, if the mass is constant, okay, mass is constant, so this m is constant, then in the equation it became F equals to m change of v over change of t. Okay, what happened is m change of v over change of t is is acceleration, right? So F equals to ma. This is the derivation only happen when the mass is constant. Okay, and we have seen there are lots of objects where it has a force and the mass is changing. Okay, such as we are later I will show you this. Maybe next time I show you when we have a rocket. Okay, and the rocket has a fuel inside the rocket. Initially, the rocket has a fuel, maybe 3/4 of the weight of the rocket, right? Before it was going up. So when it was starting to launch, okay, when we're starting to launch at higher and higher, the mass of the rocket is the red color. The mass of the rocket will be depleted. Means that the fuel of the rocket will be uh what I call decrease, taken by to burn to be a thrust, right? So in this case, the mass and this m is not constant. Okay, the mass is changing during the path. the flight. So in this case, F equals to change of mass, and let's say V is changing over change of T. Okay. So V is constant, let's say V is constant, and change of mass divided by change of V. In this case, it's not actually F equals to MA. Okay. So remember in the STPM, when you want to define, and you also have to memorize this thing because it can be asked in the STPM. When we say that Newton's second law, it is the force, resultant force is directly proportional to the change of momentum divided by change of time. Okay, everyone clear about that?
Yeah.
Okay.
Yes, sir.
Okay, so going to release all. Okay, so in this case, you can see that the question says that you can see that the mass is constant throughout the motion, throughout the after and before and after of the motion. So the force 6 Newton acts as an reject of the mass 6 kilo for, and then let's say we have a box over here, and this is 6 Newton, 6.0, 6.0 Newton, and this is mass of 2.0 kilogram and period of 12 seconds. Okay, so we can say that we can start with F equals ma because we already know that the mass of the object does not change. Okay, if it change, it will be different. F equals cannot use F equals ma. So force is 6 Newton, 6.0. M is 2 kilogram, and we have acceleration over here. So acceleration will be, how much is acceleration? 6 divided by 2. So acceleration will be 3.0 meter per second squared. Okay. So the acceleration is given already, number A. And B, find the velocity of object. We know that acceleration equals V minus U over T. Okay. And V is the one we want to find. U is 0 because it was stationary, stated in the question, stationary. And T is 12 seconds. So V is, this is A is 3.0. So V will be 36 meter per second. Okay. This is very simple, right?
Yeah.
Okay, any question? Maybe you were having problem this in the SPM. Anyone here having problem with the question? No, what? Okay. Okay, next question. Two forces, 10 Newton and 6 Newton respectively, are acting on the 2 kilogram wooden block placed on the smooth horizontal surface, as shown figure. Assume that G is 9.81. Determine A, horizontal resultant force. I think anyone here wants to try? A, what will be the first working?
We can do the, what's it called? F cos theta. So 10 cos 30 and 6 cos 45.
Okay,
Then we minus the big one minus the small one.
correct. Okay, so this is the correct way. First, you have to find this. First of all, which one positive, left or right? Assuming to the right is positive or to the left is positive. So let's assume lah, to the right is positive, to the left is negative, right? So the 10 Newton, okay, the 10 Newton, so force net, okay, equals to the right is positive, so 10 cos 30 degrees. Why 10? Why 10 is positive? Because the 10 is pushing to the right side of the diagram. Minus, why minus? Because the 6 Newton is pushing to the left of the diagram. So 6 Newton 0.0 time cos 45 degrees. Okay. And you have 4.4 Newton in the horizontal. This is A, done. For B, the normal reaction. How to get the normal reaction? Okay.
Look at the mass and relate with gravity.
Yes. That's only half of the working. One more you have to find, you have to know that, you have to remind yourself, this 6 Newton also has a lift upward, and that this 10 Newton also has a lift upwards, right?
Oh yeah.
So we have to put that into account. So let's say we draw the spot. So first of all, the 6 Newton, this yellow hard to see. Okay, this 6 Newton, 1 is 6.0 cos a sine 45. Okay, one more going upwards also, there is 10.0 Newton sine 30 degrees. Okay, and the weight of the block, that is mg. Okay, and lastly, the normal reaction that is pointing upwards, n. Okay, the n pointing upwards. So what we have here is the normal reaction is equals to mg pointing downwards. We assume that pointing downwards is positive. 2.0 times with 9.81 minus 6.0 sine 45 degrees minus with 10.0 sine 30 degrees. Okay, that you have with 10.4 Newton. Okay, so this one is actually pointing downwards. Okay, because we know that how much is pushing downwards is equals to how much is pushing upwards. Okay, both of them should be same, but only the direction. So the resultant is 10.4 Newton pushing downwards. Of course, the table will push up also with 10.4 pushing upwards. Okay, so you can say that pushing the box is pushing downwards with 10.4 Newton, the table pushing the box with 10.4 Newton upwards, right? Because it is in equilibrium. Unless one of them is bigger, either the box will be submerged into the table, or the box will be floating if one of them is having a different number, bigger or smaller. C, the acceleration of the wooden blocks. So reaction of the wooden blocks. So F equals to MA. Okay. And 4.4 equals to 2.0
times A.
2.0 times A. Okay. So acceleration is A equals to 2.2 meter per second squared. And it was towards right? Okay, because we already stated towards right is positive. Okay, done with the question number 2. Any question?
So why this F resultant?
Why F use equals to F resultant?
Why this? Oh no, I understand already. Oh, nothing. I want to ask, what is F? We use the F resultant.
Because the Newton already said the F
Yeah.
resultant is directly proportional to the change of momentum over change of time. He didn't say F. He said F resultant.
Okay.
Okay. Because if actually if you imagine there are so many forces acting on an object, like up, down, left, right, up, down, left, right, but one forces is the biggest one that move the box, the box, right? So let's say here we have so many forces acting on the box, but the box is moving towards left or right. Let's say it's moving to the right. It's because this F, the red color, is the F net. The biggest force that is pushing is to the right. The others are only a minority. So this F net is the one equals to MA. Okay, I hope you understand what is F net. That is the biggest, that is cancel all of the small forces. Okay.
Okay.
Question number 3, this one involve a vector. Okay. So a car moves with constant speed 15 meter per second on horizontal straight road. So let's say we draw, this is a car. Okay, moving towards right. And on top of the on the roof, I mean in the inside of the ceiling of the car, there was a string. Okay, a string. Oh, of course. I think it's moving to the left, right? Moving to the left. It was not moving to the right, it's moving to the left because the pendulum was swing to the right. So it goes to the left, and because of it's moving to the left, the pendulum bob was swing to the right. Make sure. So this is what happened. The pendulum was swing to the right, and it making 15 degrees with the vertical. Okay. So again, the car move with constant speed of 15 meter per second, 15.0 meter per second. On the straight road, a simple pendulum is suspended from the roof of the car. The mass of the pendulum bob is 0.1 kilogram, 0. This is what 3 significant figures. When the car starts to decelerate uniformly, the string of the pendulum, okay, it decelerates. Okay, what's interesting? Okay, so it goes back to the right. The car is moving to the right. There you have here. Okay, it's moving to the right and then decelerates. The string of the pendulum makes at 15 degrees to the vertical as shown in figure 3.5. Okay, determine the tension of the string. Okay, first of all, we have to draw the feed body diagram of the pendulum bob. So this is 15, and then this is vertical line, and this one will be the horizontal line, and this one will be the string. Okay, and this is a pendulum bob. How many forces acting on the pendulum bob? One is here, mg. One is here, and one is on the top, and one is going vertically there. Okay, so mg should be equals to the forces that pointing upwards. Okay, this is mg pointing upwards. So this one should be this one first. This is a T, tension of the line. This one will be 15 degrees. 15 degrees. Okay. So first we want to find the tension of the string over here, T. To got the tension of the string, we have to find what is the force particularly. So this force is actually T cos 15 degrees equals to mg. Okay, because how much the force pushing upwards is equal to how much weight of the pendulum bob pushing downwards. So there you have T cos 15 equals to mg, and I think this is zigzag, right? So this is 15, here also 15, zigzag angle. Okay, so we have T, okay, equals to 0.100 times 9.81 divided by cos 15 is equals to 1.02 Newton. So this number, that T over here, is equal to 1.02 Newton. Okay. We have now the tension in the string. B, the assertion of the pendulum bob. How much is the assertion of the pendulum bob? So the tension is the one who pushing on the right side or pushing on the left side. A will be equal. Okay. So of course, how much is pushing this way actually, right? It was not pushing left, it was pushing right. I think this diagram should be corrected. Okay. So on the right side. Okay. So this is a force that is pushing the pendulum bob to the right side. It was if there are no kind of this force pushing on the right side, the pendulum bob should be staying in the middle right. So this force that is pushing the pendulum bob to the right side. So this force that is in horizontal force, right? Horizontal. So we only now focus on the horizontal force. So this tension also has a horizontal force, right? Not. So this tension of the string also has a point force, and it is pushing in this way. T in this way. Okay. So if we make an equal force to the left, force by the car equals to the tension, force of the tension. Okay, then we have here negative T. I think this is negative T sine 15 degrees. And this one is MA. Okay, means that the assertion of the car itself. Okay, and the mass of the pendulum bob here, M. So what you have here is 0.100 A equals to negative 1.02 sine 15 degrees. And so the assertion of the car is negative 2.64 meter per second squared. It's a
Sir.
negative because there's rays. Yeah.
I don't understand the negative T sine 15.
Because T is moving to the left, he want to find F. So he bring the T to the right, which is negative T.
Okay, wait
T sine 15 is going left, right?
yeah.
We
Oh,
want to find F. We want to
I
find
see.
right movement. So
Okay.
left equals to right.
Maybe if I start with F car
Which is going right.
plus Ft equals to 0. And F car equals to negative Ft. Can you see this kind of working?
Okay.
Yeah, okay.
Okay.
So actually this one, I think this part is negative Ft. So F car equals to negative Ft. It came from this equation first. F car plus Ft equals 0. Okay. Then the C, the distance traveled by the car from the movement of the car start to decelerate until it stop. This one we have to use the equation, constant acceleration equation. Okay. So we have to use V square equals to U square plus 2AS. Okay. So V is 0 because it's already stopped at the end of the motion. And 15.0 squared plus with 2 times negative 2.64 and times with S, and you have 5.28 S equals to 225 and S equals to 42.61 meter. Okay, or in 3 centimeters, 42.6 meter before it stopped. Okay, this is only can be happen if the acceleration is constant during the motion. Okay. Any question? Any question, anyone?
I understand, sir.
Okay. So next, can I go to the next question? Okay. Wei Yan, are you there?
Yes.
Okay. Just checking. Nicholas, are you there?
Yes, sir.
Okay. Okay. Number 4. 40 kilogram boy stands inside a lift, assuming that G is 9.81, determine the apparent weight of the boy if the lift moves. Okay. So I just this one before we start this question, I just making a refresh of your mind how we measure R. So let's say somebody in the lift, okay, and the lift is not moving, so R equal to MA. Okay, and if the lift is going upwards, okay, upwards A, and this is the R, this is the R, and this is the mg pointing downwards. I forgot to draw the F. Okay, so wow, you start with F equals to ma, and the A over here is determined where is a positive. So it's a A pointing upwards. Okay, so everything that pointing upwards is positive. Okay, in this case, when the lift is going upwards, F here is positive because F has the same direction with the acceleration. So F, which is positive, minus mg. Okay, this is not F. Actually, this is actually R. Forgot to. This is R actually, and this is F. This is R minus mg equals to ma. Okay, so R equals to MA plus MG. This is a situation when the leaf going upwards. Okay, how about if the leaf is going downwards? Okay, with acceleration pointing downwards, A here. So if the leaf is going downwards, there's somebody there. Okay, of course the R pointing upwards, R, and the MG is pointing downwards. Okay, and we have to look back where is direction of A. So the A has the same direction with the MG, so R will be negative. Okay, so MG minus R equals to MA. Okay, so in this case, how to get the R? Mg minus Ma equals to R. Okay, so if I change back, want to compare this equation, R equals to Mg minus Ma. So you can see that these both of the equation are not same. It's because of the direction of the acceleration. So the first thing you have to see where is the direction of the acceleration. So the direction of acceleration determine where is the positive direction. Okay, so if you clear on that, then we can do this question number 4. So we have 4.0 boys standing inside the lift. Okay, assuming G is pointing downwards, determine the apparent weight of the boy if the lift moves A upwards with the constant velocity. So A equals to 0 at this point, constant velocity. So R pointing upwards, Mg is pointing downwards. Okay. So in this case, apparent weight. Okay, or we can say that apparent weight, okay, is equals to Mg because acceleration is 0. Okay, so 4.40.0 times with the G 9.81. So we have 392 Newton. Okay, because there's no acceleration, the R and Mg does not have plus or minus. Okay, this is A. For B, downwards with constant acceleration of 0.50 meter per second. Okay.
Yeah.
Goes back. So R minus Mg equals to Ma. There you go. Mg minus A. Okay, so that is 40.0. G minus A is 9.81 minus 0.50. Okay, now you have 372 Newton. Nobody tell me, Okay. C, upwards is concentration. So upwards here, this one, this is for upwards. Okay. So R equals to MA plus MG. So equals to M A plus G. Then you have 40.0. A is 9.81. Sorry, this is 0.5. Okay, 0.5. 0.50 plus with 9.81. Then you have 412 Newton. Okay. Okay, I think this is the correct question. Okay, any question? The hint is you just find out where is the acceleration, and the acceleration will be determined where is the positive direction. Okay. Any question before we proceed with the question number 5? 2 minutes, 1 minute. Okay, before we go to question number 5. Any question?
No question.
Okay, no question. Okay, question number 5. We have a pulley, and pulley is frictionless. We have also a rope, string, and string also massless string. Okay. Two objects A and B are connected by light string which passes through a smooth pulley. Object A mass 20, 2 gram, 20 gram, 2 gram. Lies a rough horizontal surface Y. Object B has 4 gram suspended in air. As shown in figure 3.6, object B is released from the rest and both objects start to move. A frictional force 4.0 Newton acts on object A. The main solution of each object tension is string. Okay. Now, first of all, if you find of if you ever encountered this kind of question, label first. Okay, we have to label. This is 2.0 kilogram, and this is 4.0 kilogram. So it means that the B will be pulling A downwards. If you B pulling the A downwards, so logically A is pointing this way. This is not gravity. This is A because B is pulling A. The whole thing is dropping at this acceleration pointing downwards. Okay, this is not G. Considerably in this question, A is pointing downwards. Okay, this is A for the whole system. So the A will be going to the right and B will be going towards bottom, and B will be pulling A. Okay. So there will be in the middle there are tension. So this one tension here and will be tension here. T top and the T at the bottom will have the same magnitude or same value. Okay. One more thing that you have to consider is a frictional force. The frictional force is pointing where? Left or right? At A.
Left.
Yes, it's pushing to the left. Okay. Because the object A is going to the right, frictional force will be in the opposite direction. Actually, it's a Newton third law, frictional force. When the things going to the left, go to the right, the frictional force will going to the left. Okay. So will be in 4.0 Newton to the left. Okay. So now we have how many things here? Let's see. The B is over here. B is F mg. Here B has a value of mg. Okay. A does not have mg because it was not suspended. Okay. Okay. Now, first of all, we focus on the top first. Okay. So focus on this side first, because we want to create a simultaneous equation of A and B. Okay. The first block on the top, we have consider because A over here is pointing downwards. At the top, A is going to the right side. So anything that going to the right side will be a positive direction. Okay, so T minus F, okay, equals to M A. This is mass of A times with A. And this F is a frictional, Fr. I put the frictional force. So T minus frictional force equals to MA. Why T is positive? T is having the same direction as acceleration you top here. You can see it's same direction of A. The frictional force has different direction of A. That's why I put negative Fr. And F equals to M mass of A times with the acceleration of the system, that is A. So I put this is number 1. So we consider next part. There is things that in this box over here, the one I just draw. So because the assertion is pointing downwards, so M mass of B, okay, times with the G, okay, minus T. I think T is pushing up, this pushing upwards because tension is pulling the B, equals to M B and the A. This is number 2. Okay. So you have two equations. MBG, MB times the G is positive because it is the same direction with the A. T is pointing upwards. Yeah, because the tension is pulling the what I call the block of the B pointing upwards. Okay. And equals to MB A. Okay. So this thing is very important because the whole answer depends on these two equations. If you
Sir,
yeah,
the T, right, the second T is pointing upward or downwards? Or
which one?
second equation, the T, the B,
Pointing upwards.
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 Wait,
Upwards.
so
Because okay,
Ah.
if I cut this part, okay, this is T pointing upwards, MG pointing downwards. Can you see? If the T had the same, let's say T had the same, have the same same direction, it already falls down, right? So the T here is the one who managed to get the B suspended. This one. This T, the one who makes the B suspended before it falls. In this case, the T is pushing the B downwards. This is pulling. The T is pulling the B. This case, the T is pushing the MG downwards. Can you see the difference of them?
sir, the list in second case, right? The T is not mg plus ma meh? Bukan ke T itu mg plus ma?
MG,
Ah,
the second equation.
yeah. Sebab
MG.
A pointing downwards also, right?
So second, okay.
Correct
Second
lah.
equation.
Ah,
Okay, second equation. What do you say?
He said T equals mg plus ma for second equation, right? You pindah
Yeah.
T to the right, you pindah. Oh,
no. Pindah, if pindah means mg minus ma already.
Okay,
no,
okay.
because resultant force is going down, Wei Hen. So mg minus T equals to ma.
Oh, the ma. Oh,
Ma is always the same. You just
Oh.
remember resultant force. Resultant force, since it's going down, right, means the weight stronger than tension.
okay, understand already. Sorry, cikgu.
Okay. Actually, I didn't understand what you were asking. What was your question?
I asked whether is T equals to ma plus mg.
T equals to
ma
Ma
plus
plus
mg.
mg.
Yeah.
T Ma plus no, it was not. If you T equals to Ma plus it, how you got this equation?
No, I thought like we follow the arrow means up equal down like this.
Oh, okay.
So ma pointing down, right? So
I think the thing that you was confused is this is not equilibrium. Not equilibrium. You know what is equilibrium?
not moving.
Not moving. If equilibrium, this one will be correct.
Yeah.
The thing now, if you release, it was not in equilibrium. So this part you cannot use anymore. Not yet. Later we learn about equilibrium.
Okay, understand.
Okay.
Thank you.
Okay, so remember this one is not equilibrium yet. Later we learn about equilibrium. Okay. So mg minus t, ma, and if we have 1, number 1 plus number 2, you will have mb G minus F equals to MA plus MB times with A. Okay, 1 plus 2. Equation 1 plus number 2. And we have 4.0 times 9.81 minus 4.0 equals to 2.0 plus 4.0 and A. So 6.0 A equals to 35.24 and A equals to 5.87 meter per second squared. Or in if you use how much this is 2 significant, right? This one also 2 significant. So A equals to 5.9 meter per second squared. Okay, and we want to find the tension, right? Asking for acceleration is also asking for tension. So we can find the tension just by replacing substitute A equals to 5.9 in any equation. So we pick number 1. So if we substitute A equals to 5.9, so T minus 4.0 equals to 2.0 times 5.9. Okay, and T equals to 15.8 Newton. Okay, and so the tension is 15.8 Newton in the system. Okay, so I think that's the end of the question, right? End of the question. So any question from you to me?
No.
Okay. So I think we can summarize. The first step is determine where is the acceleration. After you determine where the acceleration, you draw all the forces on the object. If the forces have this different direction with the A, opposite direction with the A, it's a negative number. If the force is having the same direction with A, it will be a positive number. Okay. Then after that, if everything correct with the equation correct, then you can get the correct answer. Okay. So I think I can stop here for the class. We're going to see you next week, right? Next
Yeah.
Monday, right? Okay.
Yes, sir.
So going to see you next week, and I think I will put 1 or 2 questions in the WhatsApp, and you try for yourself.
Okay.
Okay. Maybe I will put the a rocket that has a heavier mass, and then was launched. The fuel will be depleted, so change of mass. Then you can find how much the force, the thrust of the force to the ground. Okay, that one I want you to try by yourself. The rocket question, where you have a change of the mass. Okay, so see you again next week. Okay, later I think I will put some question.